Alright, now we get to the fun part, pricing the default option. I'm going to assume a generic 30-year fixed-rate mortgage, and I'm going to assume a house price that $100,000 purchase price of the house and a legitimate purchase transaction, nothing funny going on. The borrower's trying to get the best price. And I'm going to look at a couple more different mortgages, 3 scenarios. Let's do one mortgage first. This will be a $90,000 mortgage, so a 10% loan to value, or sorry, 90% loan to value ratio, 10% down payment. So $90,000 mortgage. And again, an ordinary mortgage, nothing special about it. And now I'm going to have 3 scenarios. Okay, scenario 1 is that and these are all for house prices 2 years after the origination date. Okay, scenario 1 is house prices are 100,000 or more. And then with this 90%, with this $90,000 mortgage, under that scenario I assume no losses. And that's because there's just no reason for the borrower to default on that kind of loan. If they get in trouble, worst case scenario, they sell the house. I'm going to give that scenario a probability of 0.95. 95% chance that prices will either stay the same or go higher. Then I'm going to have a possibility of the price going down to 90,000, and I'll say, say that the probability of that happening is 4%. And then a big drop, a 20% drop in home prices, I'll give a 1% chance to. And I'll come back to talking about how to set these probabilities and so on. I'm trying to make the example simple rather than complex. So when I'm making assumptions that you think are not sophisticated, keep in mind that I'm trying to do something that's simple to calculate in order for pedagogical reasons, to make it easier to show. Okay, the $90,000, I'll also say that there are no losses. That may be a little extreme. There might be some cases where there would be a default and when they're just on the borderline. But again, I'm going to assume no losses if your house is still worth at least as much as the mortgage. Now with the $80,000 loan, I'm going to say there's a 40% chance of default. That is, there's still a pretty good chance, even if the $10,000 underwater, that the borrower might continue to pay the loan. By the way, it isn't exactly $10,000 underwater because there will be a little bit of amortization of this $90,000 loan, but for our purposes, we can say that they're going to be $10,000 underwater after 2 years if the price falls to $80,000. And then if there is a default, I'm going to say we recover half of the home price, which may seem like that's a very small amount, but it just turns out that foreclosures are all very expensive. There's a lot of labor costs, there's a lot of time costs, and there's a lot of deterioration in the property, so that's actually not an unreasonable way of doing it. So we recover half the home price. Alright, so now we can do the arithmetic and find the expected default costs, which since 99% of cases we have no default costs, so we have a 1% chance of losing times only a 40% chance. That is a 1% chance that will be in the scenario, and in the scenario only a 40% chance that the borrower will default. And then we have to multiply that by the loss. So how much are we going to lose? If we get half of the home price, and the home price is $80,000, we're going to get $40,000 back. We made a $90,000 mortgage, so we're going to lose $50,000. Okay, we multiply that all out. I think that what it comes out to be is we have a $200 expected loss over all these three scenarios. That is, the 99% chance of not losing anything, and then the 1% chance times 40% that we lose $50,000, or a $200 expected loss. Now, $200 relative to the $90,000 loan amount is, let's see, we'll cross out a couple zeros, so 2 over 900, oops, not 9,000, 900, is, well, 1% of 900 would be 9, so 9 would be 1%, so we're about 1/4 of 1%, or roughly 25 basis points of expected loss, using that kind of math. Now I want to do one more example, and again, I'm making a lot of assumptions here, but now I want to change the loan. Instead of being $90,000, let's make it a $95,000 loan. And so we've got a higher loan-to-value ratio. And again, when the house price goes up, no losses. And this is an important characteristic. You can make all sorts of bad loans, high-risk loans. As long as house prices go up, you get no losses. You bailed out of even many kinds of fraud in those cases. Okay, but in the $90,000 case, I'm going to say that we have a 20% chance that the borrower will default. In the $90,000 case. Again, I'm making it up. I'm saying there's some noticeable probability, and I'm going to say that there's an 80% chance that they will default on the $95,000 loan with the $80,000 house, because then they're $15,000 underwater. So I'm going to give it an 80% chance. Now, what do my expected default losses look like? So now we have two loss scenarios. If the price goes down to $90,000, then we'll recover $45,000. We said the probability of getting to that price is 4%, and the probability of default is 0.2%. Then there's if the price goes to $80,000, we'll recover half of that, or $40,000. We said the probability is 0.01 of that happening, and then if it happens, there's an 80% chance of default. So what does that all add up to in terms of expected default cost? So we start out with the first scenario where we lose $50,000 times 0.04 times 0.2, so there's a $400 loss when we do this. And then when we do this, we get a $440 loss. Adding together is a total of $840 in expected losses. And that works out to roughly 90 basis points, a little less than 1% of the cost of the loan. So that's so when we were doing it before, we got about 25 basis points for the $90,000 loan. We got closer to 90 basis points for the $95,000 loan. So you can see that the loan losses, expected loan losses, rise very non-linearly with the loan amount. The loan losses rise sharply. And that's because the probability of default, mostly because the probability of default goes way up, because the borrower will default in milder home price decline scenarios. Okay, so there's a lot going on here. We're making some assumptions, first of all, about house prices. Next, we're making assumptions about probabilities of default in given scenarios. And this is where things like different credit scores and so on will have different probabilities. That is, for a given home price scenario, a loan to a less risky borrower will have a lower risk of default. So here's where you could modify your assumptions based on loan characteristics. So that okay, now all of these things can be estimated based on past behavior. That is, we could look at the past distribution of house prices, and we can look at national factors, local factors, and then the individual house. I mean, the individual house may change in value either because of the way it's maintained or refurbished, or the way neighboring houses affect the value, or other characteristics in the neighborhood affect that one value, or the way tastes change over time. But probably the biggest of these factors in most situations is local variation. That is, different, the neighborhood becomes more or less popular. National and individual also do matter. They are important, but the local one is a big deal. So one approach is to try to do a whole bunch of statistical estimates of of possible distributions of house prices, and instead of using these three discrete scenarios that I laid out here, use all possible scenarios based on past behavior. And then you can look at the past behavior of default probabilities. Given how much the mortgage is underwater, what's the probability of default for somebody with a high credit score, somebody with a lower credit score, for somebody with a low doc loan versus a full documentation loan? You can really try to quantify all this using historical data. But one thing I would warn you is that precision statistics are possible only with past data. And what matters is the future. And you cannot be as precise about the future. So you cannot be precise about the future. So there's actually, I think, something to be said for doing your default risk modeling with a few simple scenarios, rather than trying to achieve total precision. We can argue about that. There's a case to be made the other way, but I think a few simple scenarios is actually not such a bad way to price default risk. And I think that the three scenarios that I posited here actually yield a pretty reasonable ballpark estimate for how default losses will play out on a mortgage. And I think you can see some key points. One is that the default option, especially when the down payment is 10% or more, is very much a deep out-of-the-money option. That is, when you have a deep out-of-the-money option, most of the time it expires worthless. And when we're thinking of this prepayment option, with the 10% down payment, we posited that 99% of the time that default option expired worthless. So it's one of these things where you rarely lose money, but when you do lose money, you lose a fair amount. And that is a characteristic of deep out-of-the-money options. And that's an important characteristic of the default risk in mortgages. In most circumstances, even bad loans where the borrower and the mortgage broker lied on the loan application, the credit score is bad, The characteristics of the loan are bad. Most of the time, you're going to be bailed out by price increases. You're going to see another way of putting that is you're going to see a lot more type 2 errors than type 1 errors. That is, a lot more instances in which you turn down a loan and it turns out the loan would have worked out fine because home prices wouldn't have fallen so much. And you're going to make relatively few type 1 errors, that is, cases where you actually suffer default. But that's so you do have this option that's deep out of the money, and you can be tempted to write a lot of these options to pick up small profits. These, if you can charge 20 or 25 basis points, and most of the time you end up making no payouts, you can sort of make money for a long time, and then you get killed in the instances where you get a lot of house price declines. So that's certainly one of the insights that I want you to draw from this analysis.